So basic integration rules is basically a review of everything that we've had. So you see all the handy dandy little forms right there. So find each integral. Integral 2 over square root of 1 minus x squared dx. Well, first off, let u equal x, and a is 1. That gets us 2 times the integral of 1 over square root of a squared minus u squared du. That's an inverse trig. That's arcsine, so 2 arcsine of x plus c. On b, let u equals 1 minus x squared, because they're very similar but not quite. Derivative is negative 2x dx. Oh, hey, I've got a replacement, so this is by substitution. So negative du equals 2x dx. So our integral is negative du over square root of u. Integrate that is going to be negative 1/2 plus a whole is u to the 1/2. So that's negative 1 times u to the 1/2 divided by 1/2 plus c, which gets us negative 2u to the 1/2 plus c. Our u is 1 minus x squared, so that's negative 2 times 1 minus x squared to the 1/2 plus c. We could also write that as a square root instead. On c, let u equal 1 minus x squared again. Du equals negative 2x dx. That happens to be the exact same. Oh, but oh. My apologies, that should not be a square root on the bottom. That's why it's just negative du over u. So we're actually doing the integral of 2x over 1 minus x squared. Sorry about that. And let's just make it nice and pretty instead of that awful writing that I had there. So it's actually the integral of 2x over 1 minus x squared dx. Okay, that's why we get down to the integral of negative du over u. That gets us negative natural log of the absolute value of u plus c. So equals negative natural log of absolute value of 1 minus x squared plus c. Okay. Example 2, integrating from 0 to 4. So we can separate that into integral from 0 to 4 of x over x squared plus 16 dx minus integral from 0 to 4 of 7 over x squared plus 16 dx. On the first one, let u equal x squared plus 16. Du equals 2x dx. Divide by 2, so 1/2 du equals x dx. We can do substitution there. So that's integral 1/2 du over u minus, pull out the 7, and then you look at that second one, we can write that as x squared plus 4 squared on the bottom. So let w equal x and a equal 4. That gets us that's an arc tangent, and since our a is 4, it's going to be 1 over a, so that's why it's 1/2 natural log of u minus 7, 1/4 arctan of x over 4. And u again from that beginning is x squared plus 16. And now we just plug in the 4 and the 0. So 4 squared, 16 plus 16 is 32, minus 1/2 natural log of 0 plus 16, so natural log of 16. When we subtract, well, we can pull out the 1/2, and then when you subtract, you divide, so that's 1/2 times the natural log of 32 divided by 16, which is the natural log of 2. Arctan of 1 is pi over 4, arctan of 0 is 0. And that's about negative 1.02787. So to 3 places, negative 1.027 truncated, or negative 1.028 rounded. Watch out for, on technology, trapezoid rule can give us a good approximation of something, and we can use the fundamental theorem of calculus. Fundamental theorem of calculus gets us 6.213. Trapezoidal rule gives us 7.5. Okay. Trapezoid rule doesn't always give us a good approximation when we're working with it. Now, example 3, we can rewrite that. The x to the 4th is x squared squared, and 4 is 2 squared. that looks like arcsecant, so 1/2 arcsecant x squared over 2 plus c. So on example 4, evaluate integral of 6 over e to the x plus 6 dx. Well, we have to adjust that top a little bit. Notice all I did was add and subtract the same amount. Now I can separate that into two separate integrals. And that first one gets us integral of 1. Second one, I've got to let u equal e to the x plus 6, du equals e to the x dx. So now I can do that as x minus integral of du over u. So x minus natural log of u plus c, and u is e to the x plus 6. Example 5, let u equal -3 cosine of x. Du equals 3 sine of x dx, which we've got a sine x dx, but we need to move the 3 over, so 1/3 du equals sine x dx. So we've got the integral of 1/3 integral of e to the u du. That's 1/3 e to the u plus c. So that's 1/3 e to the -3 cosine of x plus c. Procedures for fitting integrands to basic integration rules. Expand the numerator if you need to. Separate the numerator. Complete the square if you need to. Divide improper rational functions. Add and subtract terms in the numerator. Use trig identities. Multiply and divide by the Pythagorean conjugate. All work. So integral sine squared x dx. Well, sine squared is same as 1 minus cosine 2x over 2. That's a double angle formula. Separate that into two separate fractions, 1/2 minus, well, two terms, 1/2 minus 1/2 cosine of 2x. Let u equal 2x, du equals 2 dx. So 1/2 du equals dx. So we've got 1/2 x, because that's the integral of 1/2, minus the integral of 1/2 times 1/2 cosine of u du. So that's 1/2 x minus 1/4 integral of cosine u du. So that is 1/2 x minus 1/4 sine of u plus c. Again, u is 2x. And that simplifies it.